Rossmann is the largest drugstore chain in Germany. In the year 2014, it generated a revenue of 7.2 billion euros, with more than 3,000 stores and almost 44,000 employees in Europe. Despite its size and sales performance, retail stores are facing increasing pressure from disruptive technologies as e-commerce, for instance. In fact, just recently, Rossmann's biggest competitor, Schlecker, has gone bankrupt. To cope with this ever-challenging market situation, Rossmann wants to predict its future sales performance with the means of data science. Exploring the given data, we see that sales performance correlates with the number of customers. However, there won't be customer information in the test set, so we cannot use it for modeling. When looking at the categorical information available for each store, we see that sales is rather equally distributed over the week. Nevertheless, as expected by intuition, the amount of customers is higher on weekends than during the week. Furthermore, promotional campaigns positively influence sales and the amount of customers. When plotting web scrape data on a map, one can see that Rossmann's stores are rather equally distributed over Germany. Furthermore, the color code indicated that there is a rather equally distributed competition distance in place. To come up with the first modeling approach, we explored the data using an autoregressive correlation method. From this, we saw that sales can actually be predicted from past sales because there is a 7-day seasonability lying within the data. So we took the autoregressive model as a baseline and compared it with linear and decision tree regression. We can see that the baseline model explains the sales pretty decently. Comparing it with a linear and boosted regression tree model, we see that the tree has performed best. So what is the model worth? We actually trained the model using the 7-day seasonability sales and assumed that we had this information even in the test sample. The obvious reality is that we only have the time series feature for the first few observations of the test sample. We conclude that the time series modeling is challenging because the error builds up when we try to predict the far future. In subsequent research, we might want to explore other models that try to adjust for this issue.